Welcome to this video for rabbits and foxes. This is for the AQA Computer Science Paper 1 examination that will take place in summer 2017. What I intend to do in this video is to give you an overview of what the system actually does, how it works, the key data structures and the key algorithms, and by the end of it you should go away with hopefully a good understanding of how the system works as a whole and the key algorithms that you might get asked about in your exam. So firstly, a quick overview of the program itself. What we have is a simulation of a rabbit and fox population on a landscape represented as a grid, which is represented by a two-dimensional array in the code itself. You can set the size of the landscape when you start the simulation. The simulation itself can be run with default settings, or you can customize those settings. There are menu options for that. The way that it works is we have time periods, and as the simulation advances through each time period we can inspect the current state of the landscape and we can look at things in more detail, and we'll look at that later. And the key thing for this is that unlike previous paper ones or previous comp ones on the old syllabus, this is a fully object-oriented implementation. So what we have is this landscape populated by rabbits and foxes. By default this is a 15 by 15 grid. You can see it goes from 0 to 14. You can change those settings in the simulation itself, and F in this case represents a fox, and the number of foxes can be set by the user before the simulation actually starts. Any numbers on the landscape represents where we've got a warren, and the number is the number of rabbits in a particular warren, and again we can set the number of warrens before the simulation starts. Note that it is possible for any location to contain both a fox and a warren in the same position. And if you've never come across this kind of thing before, this is a fairly standard what's called a predator-prey cycle. You may have studied something like this in biology, where you can see an example on this graph. As the number of rabbits increases, you'll notice that the fox population grows because they got more food, and as the number of foxes increases, then the rabbit population starts to dwindle. So before we start looking at the inner workings of the code, it's worth just looking at some of the attributes. This, as I say, this is an object-oriented program, and one of the key classes is the animal class, and some of the attributes of this are worth looking at. So firstly, each animal in the landscape has an ID, which is its unique identifier. The age of the animal is stored, which is its current age in years. We'll look at the code in more detail later, but we'll note that foxes age quicker if they don't eat enough, and we'll look at food units and how that applies. Each animal has a natural lifespan, which is the age at which an animal would die of old age, and the default values for that are set to 7 for foxes and 4 for rabbits. And another attribute is what's called probability of death from other causes, and this is a percentage chance that an animal will die in any particular time period from causes other than starvation or from old age, or in the rabbit's case, being eaten by a fox. The fox, as we'll see later, is a subclass of the animal class, and it has some of its own particular attributes. So one of those is food units needed, and this is the number of units of food, i.e. the number of rabbits that a fox needs to eat in any particular time period to stay healthy. The default value for that is 10. If it doesn't have enough food, then the probability of it dying increases. And then the food units consumed is the number of rabbits that it's actually consumed in the last time period. So if it's eaten enough, fine. If it hasn't eaten enough, then it ages faster. If it doesn't eat any at all in a particular time period, then that fox will die. Like foxes, rabbits are also a subclass of animal, and they have their own attributes. So one of those is the reproduction rate, and this is a number that represents the chances of a rabbit mating in a particular time period. I suppose the detail of that is having a kit, a baby rabbit that actually survives that time period as well. And then they also have their gender, and there's a 50-50 chance of either gender. So as we mentioned before, the rabbits actually exist in warrens. So there's a warren class And the warren attributes include the rabbits. The rabbits is a list containing all of the rabbits that inhabit the warren. This is an example of composition aggregation. Composition aggregation means, in this case, that the warren contains the rabbits. So if the warren is destroyed, the rabbits are also destroyed. Another attribute we have is the periods run. This is the number of time periods that the warren has existed within the simulation. The rabbit count is a number of rabbits that live in the warren. And then we have already spread. This is an indicator of whether the warren has already spread into a new warren. Basically, when a warren contains 99 rabbits the first time round, then a new warren is generated in a random position on the landscape. But this can only happen once, so it keeps track of whether or not it's already spread. So now we're ready to start looking at the actual code itself. The first thing to point out is it's a console application, and the first thing we might notice is under the users, it uses the math library. If you're not familiar with the math library, this is the Delphi Basics page, and it lists all the functions included in the math library. Probably worth you having a look at this. So now we're going to start looking at some of the class definitions, and we're going to start with this animal class. First thing to note is these properties here are protected. What this means is that these are known to all subclasses in the hierarchy. If they were public, like these methods here, it would mean anything can access them. Being protected means that subclasses can access them, but nothing else. If they were private, only code within the class itself can access it, meaning subclasses couldn't. One or two other things worth pointing out. You'll notice we're using the double data type for some of these values. The double data type, if you're not familiar with it in Delphi, is a floating point data type. It uses approximately 15 digits of precision. Something else worth looking at is where we see something using the virtual modifier here. What this means is in this case, the calculate random value method can be overridden in a derived class, i.e. a subclass can implement its own method. So this is the animal class that we're looking at the moment. We know that there's a rabbit and a fox subclass, so they can then implement their own version of this method with it being virtual. This also applies to some of these methods here as well. So you can see calculate new age, check if dead, inspect, and check if killed by other factor are all virtual, so they can be overridden by a derived class, by a subclass. And this is the fox subclass. Again, a few things worth pointing out here. You can see that the constructor, i.e. the new method for when you're creating a new fox, is set as overload. What this means is, although it's declared in the parent class as animal, the one in animal takes 3 parameters. You'll notice that this version only takes 2. So overload allows 2 or more methods to have the same name. The overloaded version of the method only requires 1 parameter. The correct method will be invoked by the code depending on the number of parameters used. So if you are creating a fox and you pass 1 parameter to it, it will call this version. If you pass 3 parameters to it, it will call the one from the parent class. So just to look at that in a bit more detail, we can see that fox is a subclass of animal, so it inherits the constructor from animal, but it also implements its own overloaded method of the new constructor. So this one only requires 1 parameter, which is called variability. Variability itself is an integer, as you can see. It represents how much variability there will be between different instances of an animal or a warren. In warrens, this would be the number of rabbits in each warren. Individual rabbits and foxes also vary in terms of their lifespan, their probability of death from other causes. For rabbits, their reproduction rate, and for foxes, the amount of food that they need to eat. The next thing we'll look at is this type genders. This is an enumerated type. Anything that's declared as this type genders, can only contain one of those 2 values, male or female. They're actually stored internally as 1 and 2 by default, so it is actually possible to add and subtract or using for loops, although that's not how it's actually used in this case. This is the rabbit subclass. Remember, it inherits everything from the animal parent class. The rabbit implements its own constructor. In fact, it implements two constructor methods here. The first one accepts one parameter, variability. The other one accepts variability and parent's reproduction rate. So when a rabbit is created, when it's instantiated, to use a proper term, we can invoke the constructor method with either one parameter, with two parameters, or with three, in which case it would call the parent class constructor. And now we've looked at those classes, just for completeness sake, here's a class hierarchy diagram for the animal parent class, and then we've got the fox and the rabbit subclasses. So this is the definition of the Warren class. It's got various private attributes as part of this class. Most of these are fairly self-explanatory. Note the array of rabbits. This is an unsized array, and that will be dealt with later. There are several private methods, meaning that these are only accessible within instances of the Warren class itself. There are two constructor methods. Note the overload directive there, allowing a Warren to be created by calling either the first one with one parameter or the second one, which accepts two parameters. And again, here's a class diagram. So this is the class diagram for Warren. This is the class definition for location. Note that this contains a couple of public attributes here, as well as the constructor method. One of the things you might be wondering is, well, why are the fox and the Warren both public, meaning that they'd be accessible from anywhere in the programme? Maybe the possibility would come in the exam that you might need to write a get and a set method for each of these. Certainly it's fairly questionable programming practice to leave them as they are, so that's something to think about. And this is the definition of the simulation class. So the simulation itself is declared as a class. Again, slightly strange way of doing things. I suppose in theory it would allow you to create multiple simulations within the program running simultaneously, perhaps, although I wouldn't really recommend that. Just one or two things to point out, really. It's fairly self-explanatory. It's a place where we've got a lot of the methods that will be used within the simulation to actually make the simulation run. The simulation contains the landscape. So the landscape is a two-dimensional array. It says array of array, two-dimensional array, i.e. a grid of locations, which we've just looked at. Again, note that the array isn't given a fixed size here. And this is the class diagram for simulation. Note that everything here is private, apart from the constructor. So now we've had a look at the overview of the program and the classes, the data structures and so on, we're going to have a look at how the program actually executes and start looking at some of the algorithms. So the program begins execution right at the bottom of the source code. This will be on line 843 of the source code, and all it does is it calls the main procedure. So this is the main procedure. No, it is a procedure. There are no parameters, there's no return value, so in Pascal it's a procedure, not a function. There are various local variables that get declared here. These are only used within this procedure. Again, most of them are fairly self-explanatory. Note that sim is going to be declared here, and this is of the type simulation, which is the simulation class. And in case you've forgotten, this is the class definition. Lots of private attributes, lots of methods. The only public method is the constructor. So the code starts with a repeat until loop. And reading ahead, we can see that it's going to keep on repeating until menu option equals 3. So the code will display a menu with three options. The user's input will then be read into this variable menu option, which should be an integer in the range of 1 to 3. Options 1 and 2 will actually run the simulation. Option 3 is to exit, hence the repeat until menu option equals 3. If the user chose menu option 1, then they chose to run the simulation with default settings. So this block of code here will set the local variables with the default settings for the simulation. You see the default landscape size is 15, and when it displays it on the screen it will show 0 to 14. The else branch of this code means that the user chose to use custom settings, i.e. they selected menu option 2. So if menu option equals 1, else. So it goes down this branch for menu option 2. So they're asked to input the values, and these are then assigned to the same local variables that were used for menu option 1. And this is what the output looks like for that particular option. So finally, after setting those values for the simulation itself, we need to create a new instance of the simulation, and this is what's happening here. The constructor method, new, is invoked, and an object is created called sim. Sim was declared as a local variable, remember, at the start of this procedure. And just as a reminder, this is what the signature of this constructor that we're calling now actually looks like. So you can see these are the parameters that it's expecting to receive. So this is the code of this method itself. This is simulation.new that we're looking at. So let's look at this in more detail. So as expected, the constructor expects 5 parameters to be passed. Note that everything's been passed by value, there's no passing by reference here. So the method declares these 4 local variables. These are separate from the private attributes that are declared as part of the class, so they only exist whilst the constructor method, whilst this code is actually running. These variables that have been initialized here are part of the class. These are the private attributes of the class. And again, just a little reminder, this is the class definition here, so you can see that these attributes are what are being given values in this part of the code. You can see that landscape size and variability are being given values here. These are the values that are being passed to the constructor method when it's invoked. These might have been set by the user if they're using custom settings. Next, the randomize function is called. You're probably familiar with this. This is the Delphi Basics page that explains that randomize is needed to get a new random seed. This basically stops the program always generating the same set of random numbers every time you run the program. Next, the setLength function is called, and it passes to this function landscape, which is the 2-dimensional array, and it passes the landscape size twice because the same dimension or the same figure is used for each dimension of the 2D array. And again, we're looking at Delphi Basics here, and this is the page for setLength, worth having a look at if you've never used it before. And what this does is it can actually resize an array. Because this is a 2-dimensional array, we need to pass the array and the sizes in both dimensions, both of which are landscape size. If you look at the Delphi Basics page on this, you see that there are 2 variants of the function, and we're using the second variant, i.e. we're setting the length of the dimensions in the array. And here's just a quick reminder that landscape was initially declared as a 2-dimensional array of locations, but no dimensions were initially given. And a reminder that this array of locations means the location objects, where a location can contain rabbits and foxes. And the landscape size that it's using here, don't forget, was passed to the constructor when it was called. So landscape size input was passed to it, that goes into landscape size, that gets passed to set length so that it can resize the array. Next, there's a call to this procedure, create landscape and animals. This particular procedure is a method. It's private to the simulation class. And this is the procedure itself that we're looking at. So let's take a closer look at what it actually does. Firstly, these local variables are declared, x, y, f and w. These are going to be used as loop control variables. X and y are used to loop through the two dimensionals of the landscape array representing the x and y coordinates. F and w here are used to loop through foxes and warrens. So here's our first loop. You can see we've got a nested for loop which is going through every location in the landscape using x and y as the loop control variables. And these are going to be the indices into the landscape array. So it's looking at landscape x, y, and it's going to go through every location in that landscape. And you can see what it's actually doing is calling location.new. Just note the use of -1 here. That's because we're using a zero bounds array, so it's starting at 0. So if, for instance, the size is 16, the array is going to go from 0 to 15. That's not the way we've usually used arrays in Pascal in the past, but bear in mind that that's how it's often used in other languages, that arrays would normally start at 0 rather than 1. So I mentioned we've got this call to location.new. That means every position in the landscape array is now set to an instance of location. So it's creating a location object which is stored inside each position of the landscape. And recall that a location can contain a fox and or a warren. When this constructor is actually invoked, it creates a new instance of location and it simply sets fox and warren attributes both to nil. This simply indicates that there's no fox and there's no warren in that particular location. So the next thing it does is it checks this variable fixed initial locations. This is a boolean and it was passed to the procedure when it was called. It indicates if the user wants to start the simulation with the default warrens and foxes already on the landscape. If that's the case, then 5 warrens are added to the landscape. To do this, it needs to invoke the warren constructor, i.e. the new function. And it needs to do this 5 times, and it assigns the resulting object from that. So it's creating an object and the resulting object gets assigned to a position in the landscape. So these fixed positions each will now contain a warren. Just recall that landscape is a two-dimensional array of locations, so the first warren that's being created here goes into position 1, 1. And recall that a location can contain a fox and a warren or a warren, and in this case we're just adding warrens. Again, a reminder of the warren class. Recall it contains a number of private attributes here, but its constructor only requires us to provide a couple of parameters. In fact, there are 2 constructors and we can either provide one parameter, the variability, and optionally we can also provide rabbit count. In this case you can see we're providing variability and rabbit count. This is the method itself, the constructor for warren. And this is called every time we want to instantiate a new warren, i.e. we want to create a warren object and add that object to the landscape. So firstly, these private attributes are set. Variability and rabbit count are values that in this case get passed when we invoke this constructor method. So we're passing variability input, we're passing rabbit count, and they get put into these private attributes that belong to warren. Next, we call the setLength function again, which we can use to resize an array. In this case, we're passing the rabbits array and we're setting the size to max rabbits in warren. Again, possibly something that you might be asked to change. So, for example, use a constant, or it could be a value that's set by the user. Remember, rabbits is an unsized array of rabbit objects. It's private to the warren. I.e. in each warren object it can only contain an array of rabbits up to a maximum of 99. And recall that each rabbit is going to be an object in itself. So at this point now the rabbits array should be able to store a maximum of 99 rabbits in the warren. Now that we've resized the array, we need to start adding some rabbit objects to the array. The number that we need to add is set by rabbit count, so you can see we've got a for loop that's going from 0 to rabbit count -1. Self, in this case, refers to the current Warren object, so it's referring to the current Warren's rabbit count. So in order to add new rabbits to the array, we need to invoke the rabbit constructor, i.e. rabbit.new. This is another example of an overloaded method. We can call it with one parameter, variability, or we can pass two parameters to it. And in this case, we're just using the one, we're just passing variability. So this is the constructor, and you see it's the one that uses one parameter. It starts off just by setting some of the default attributes for a rabbit, its default reproduction rate, lifespan, probability of death. And then it calls its own constructor. Notice this is the one with three parameters. This is actually the inherited constructor from the animal parent class. There's no return value from this call, so a new rabbit isn't being created here. It's just calling this function so that it can change its own attributes. And this is the animal constructor that's being called. It sets the attributes for whatever object is currently calling this. In this case, it's being called for a rabbit from the rabbit constructor, but it would do exactly the same if you were creating a fox, for instance. When you create a new fox object, if you called this constructor, it would set those attributes as well. And this process then is repeated for the other four preset Warrens, and the Warren count variable is then set to 5. We then move on to the creation of the foxes. This is if we're using, remember, the default options. We'll look at the else branch later for creating the Warrens and foxes with the user's own settings. I'm not going to dwell too much on how foxes are created. You see it's very similar to how the Warrens and the rabbits within the Warrens are created. It calls the fox constructor, and the object is now part of the landscape in the landscape array at that particular position. So if it's not going down the else branch, in effect that's the end of this procedure. So simulation, create landscape and animals is what we've just been looking at. And this was called, if you recall, from the simulation.new constructor. And so we would return now, execution would now continue from here and move on to draw landscape. Draw landscape is a private method. It's part of the simulation class. This is the code itself. You can see it declares a couple of variables here, x and y, which it's going to use later on for iterating through the landscape. So draw landscape, as you probably guessed, is going to draw the landscape to the console output. After it's displayed the current time period, then it moves on to this for loop, and this is used to output the column headings on the grid. It uses x as a loop control variable, and by default is going to go from 0 to 14, although remember landscape size can be changed in the settings. Every time it iterates around a loop, it displays the value of x, so it will display the numbers from 0 to initially 14, followed by this vertical line. These are simply the column headings. After this small for loop here, which is simply outputting these horizontal lines which appear here underneath the column headings, we then move on to this next for loop. This goes through each row of the landscape using y as a loop control variable. There's a nested for loop within this that loops through each column using x for the current row, or within the current row. If the current position contains a Warren, this is the not self.landscape.warren equals nil, then it looks at how many rabbits are in that Warren by calling getRabbitCount method. This simply returns a rabbit count property, which is private, so it can't be directly accessed. If there are fewer than 10 rabbits, it displays it as an empty position, which is the code we've got here. Otherwise, it will display the number of rabbits in the Warren. If there's a fox in that position, this is the if not self.landscape xy.fox equals nil, then it will display an F. So it's simply going through each position in the landscape, displaying the number of rabbits in the Warren, or an F for a fox. And then we would return back to this point in the execution of simulation.new, so we're back here again. So having set everything up, we are now entering our main program loop for while the simulation is running, this big repeat until loop. It displays a menu, it gets the user's option choice, and it will keep on doing that until one of three things happen. Either there are no warrens left, so the simulation would then stop, or there are no foxes left, or the user has selected from the menu option 5, which means exit. The first menu option, option 1, means to advance to the next time period showing the details. The time period, this is a private attribute of simulation, gets incremented. Show detail gets set to true. Note that option 2 is almost the same. If you look at option 2, the only difference is that show detail gets set to false. So after setting those, we call this advance time period. So let's look at this in more detail. Advanced time period is a private method. It belongs to the simulation class. It's quite a large subroutine. As you might expect, given that its purpose is to make all of the changes to the landscape over a single time period, it's got quite a lot to do. So one of the first things it does, you'll note we've got another nested for loop again, using X and Y to go through the entire landscape, looking through each row and each column within each row. So we're now going through every position within the landscape. This block of code that we're looking at here firstly checks if there's a warren in the current position, okay, if warren is not equal to nil. If show detail is true, that means option 1 was selected from the menu, then it will output the warren's position and it calls the inspect method on the warren. As you can see, this simply outputs the periods run and the rabbit count for that warren. It then checks if there are any foxes in this particular position of the landscape. If so, then it calls foxes eats rabbits in warren. Again, this is a method. It passes to it the X and Y coordinates of the current position. So this is the foxes eat rabbits in warren method. It belongs to the simulation class. As well as receiving the coordinates as parameters, there are a number of local variables that get used within this procedure. The first thing it does is to get the number of rabbits in this warren by calling getRabbitCount. This method here will return the number of rabbits, and it stores that return value in rabbit count at start of period. As you can see, this is an integer that's declared. It only has scope within this particular procedure. This is the getRabbitCount. As you can see, as a function, all it does is it takes the rabbit count attribute and it returns it. It's simply a get method. It gets that value and returns it. We then have another nested for loop that goes through each position in the landscape. It then checks if there's a fox in that particular position. So it's looking at the X and Y coordinates that we're using here as our control variables, and it says if it's not, if the fox attribute is not equal to nil, it meaning that there is a fox in that position. So if there is, it calculates the distance between the warren and the fox, and it does this by calling the distance between method. This is the code for the distance between method. It belongs to the simulation class. It takes the fox's coordinates as x1 and y1, and it takes the warren's coordinates as x2 and y2. It works out the distance between the two coordinates, which is what's going on here. You can see that the value that gets calculated then gets assigned to distance between. This being the name of the function means that this is the return value. In case you're wondering, this is the formula that's being used. It's the distance formula. You might remember it from your GCSE maths lessons. If you need to know how it works, go to this URL. Returning to execution then in foxes eat rabbits in warren, we're up to this point. We've got the distance between the fox and the warren. After getting the distance, it then works out what percentage of rabbits from that warren are going to be eaten by a fox. If there's a fox that's close by, i.e. it's less than or equal to 3.5, whatever the units are, 3.5 squares, that fox is going to eat 20% of the rabbits. One that's a little bit further away but still within a distance of 7 will eat 10% of the rabbits. Otherwise the fox is too far away, so it's not going to eat any rabbits in that warren in that particular time period. The number of rabbits that are going to be eaten, the rabbits to eat, is calculated using that percentage that we've just calculated there, and then the whole thing is rounded to a whole number. The value rabbits to eat is then passed into eat rabbits. The eat rabbits method belongs to warren. This is the code for the eat rabbits method. As you can see, it's a function. As well as accepting rabbits to eat as a parameter, it also will have a return value of an integer. It also declares two local variables, death count and rabbit number, both integers. After initializing death count to 0, it then compares rabbits to eat with the rabbit count of the warren. If the fox has been calculated to be eating more rabbits than actually exist in the warren, the number to eat is set to be the total number of rabbits in that warren, i.e. the fox will eat all of the rabbits in that warren. We then enter this while loop, and this will continue while death count is less than the number of rabbits to eat, i.e. the number that's already been eaten so far is less than the total number that are to be eaten. Inside the loop, it picks out a random rabbit, and it picks its number at random, and it checks if that rabbit exists. If the rabbit exists in that element of the array, i.e. it's not nil. If so, then what it will do is it will remove that rabbit by setting it to nil, so it's now a dead rabbit, and it increments death count, so the number of rabbits that have been killed increases. And this will continue going round this loop until the correct number of rabbits have been removed. Worth pointing out that it has to check if it's already nil, because if a rabbit has been killed and then it picks out a new random rabbit, it might have picked out a dead one. It then calls compress rabbit list, and this is a method, and it passes to this death count as a parameter. This is the code for compress rabbit list. The purpose of this subroutine is to go through the rabbits array, and when it finds an element in the array that's empty, i.e. a rabbit has been killed, it's been removed from the array but its element still exists, then what it does is it will go through subsequent elements in the array and shift them down. So it will basically remove a dead rabbit from the rabbit array and shift everything down to fill its position. And it will do this until all the rabbits have been shifted down to the new last position in the array, which is calculated by rabbit count minus death count. So having returned from compressed rabbit list, we've got this final line of code in eat rabbits here. Rabbits to eat is assigned to eat rabbits. Remember, eat rabbits is the name of the function, so in effect rabbits to eat is the return value from the function. And we've now returned from our call to eat rabbits, and we have our return value, which is our food consumed. This is the number of rabbits in the current warren that have been eaten by a fox, and that fox was in proximity to the warren. And that value, food consumed, is now passed into the give food method of the fox that is in that position of the landscape. This is the give food method that we're referring to, and this simply adds that number, which is stored locally as food units. It adds that number to food units consumed this period, which is an attribute of the current fox that we're looking at. Finally, if show details was selected from the menu, the details of how many rabbits were eaten by this fox get displayed to the console. And our loop will now continue doing this for every position in the landscape, i.e. it will check if there's a fox there, it will work out the distance between the fox and the current warren, it will calculate how many rabbits will be eaten, it will update the rabbits array in that warren, and it will update the amount of food consumed by the fox. And that's the end of our call to foxes eat rabbits in warren, and we're returning back to the advanced time period subroutine. Recall that we're currently in the middle of a nested loop, and it's working its way through each position in the landscape. We then have this if statement, which is actually calling needs to create new warren, which is a method which returns a Boolean value. So this will return a true or false. So it's basically saying if the return value of this is true, then it will do this. So this is the need to create new warren. As you can see, it's returning a true or false value. If it returns true, it creates a new warren. The way it works is if the number of rabbits currently in the warren exceed the maximum allowed and the warren hasn't already spread is set to false, by the way, in the warren constructor, then we set already spread to true and we'll return true, otherwise we return false. This is this idea of when a warren gets full, then it can spread and create a new warren. If it's already spread though, then it can't do it again. So if it returns true, then we need to follow through with this call to create new warren. Create new warren is a method belonging to the simulation class. It's a procedure and it will iterate, so we've got this repeat until. It's using the x and y coordinates again, and it will iterate through the landscape, but the way it does it this time is by selecting a random position. So it doesn't go through it in turn as we've seen previously. It will pick a random x and y coordinate, selects a random position in the landscape until it finds one that doesn't have a warren already there. So it picks a random position, and if the warren equals nil, that means there's no warren already there. So it's found a position with no warren already there. It will then create a warren at that position, which is what it's doing here. Notice if we've set show detail, then it will show some details of that, where that new warren has been created. And the way that it creates it, it's calling the constructor here that only accepts one parameter. This is the constructor that we're talking about with one parameter. This isn't the same as the one we looked at earlier when the landscape was being set up at the start. That one took 2 parameters. The only difference really between the two is the way that rabbit count is calculated for a warren that has spread as opposed to one that gets added at the start of the simulation. The way that this is done is it uses the calculate random value method. This is the calculate random value method. In actual fact, this is the one that belongs to the animal class, but warren has one that's identical to this. It uses exactly the same code, and it basically takes a base value and variability to calculate a random value, and that then becomes the return value, which in this case will be used for the rabbit count. Our code will then have a for loop that starts creating those new rabbits. So it will go from 0 to rabbit count, and so that now says how many rabbits we need to be creating. It will fill the array with new rabbits, and it will pass variability to the rabbit constructor when it creates those rabbits. So we've now got a new warren with an array of rabbits. So it checked whether we needed to create a new warren. It did that, and now we've got this call to advanced generation. This is the code for advanced generation. The first thing it does is it increments the periods run. This is the attribute belonging to the warren that says how many time periods this particular warren has been in existence. It then checks if there are still any rabbits in the warren, i.e. rabbit count is greater than 0. If so, it will call the kill by other factors method, and again it passes show detail to that as a parameter. This is kill by other factors then. The purpose of this subroutine is to reduce the number of rabbits for those that might have been killed by other non-fox factors, i.e. they haven't been eaten but they're dead anyway. It declares a couple of local variables, and then it uses this for loop, and it uses this to iterate from 0 to rabbit count -1, i.e. it goes through every element in the rabbit array. It will call check if killed by other factor for each rabbit in the array. This is inherited from the animal parent class. This is the code itself. It gets a random number, and if it's less than the probability of death by other causes times 100, then it kills the animal. In this case we're calling it on rabbits, but you could also do it on foxes. The probability of death by other causes attribute is inherited from the animal class. It's a random value that's created when the animal was constructed by the constructor method, and a value of true or false will be returned depending on if that animal has been killed. And you can see again this has been used as part of an if statement, so if the value returned by that is true, then we will branch down through this block of code here. So i.e. the rabbit dies, we will set that element in the rabbit array to nil, meaning that the rabbit no longer exists, and we'll increment the death count, and then we continue iterating through all of the rabbits in the current warren. And once we've done that, we will finally call compress rabbit list. Again, this will remove any empty elements in the array for rabbits that have been killed off, and if show detail was selected, it will output the number of rabbits that were killed by other factors on this time period in this warren. Returning back to advanced generation then, we then check again if there are rabbits in the warren, because they might have all been finished off in the last subroutine, and if so, if there's still rabbits there, we call age rabbits, again passing show detail to it. This is age rabbits. It also loops through each element in the rabbit array in the particular warren, and for each rabbit it will calculate its age, and it will check if that rabbit has now died of old age, and if so, it will remove the rabbit. Calculate age and check if dead are both methods that are inherited from the animal parent class. Both, as you can see, are fairly straightforward. So after aging the rabbits, we check if the rabbits in the warren can mate. This occurs when the number of rabbits in the warren is between 1 and max rabbits in warren, which by default is 99, and also that there are males in the warren. To check if there are males in the warren, we've got this contains males. As you can see, this is a method that will return a true or false value. It simply iterates through each of the rabbits and each of the rabbits in the rabbits array in the warren, and it will return true if any of them are male. It checks the gender of each rabbit by calling the isFemale method here. This code that we're looking at is a method of warren, and it can't access the gender directly because that's private, hence the need to call this. So if we've calculated that we've got at least one rabbit in the warren, and we haven't got too many rabbits in the warren, and there are males in the warren, then we're going to call mate rabbits. This is the mate rabbits method. It loops through every element in this warren's rabbits array. This is the code here. It checks if the current rabbit is female, and if there's still room in the warren, i.e. the max rabbits in warren hasn't been reached yet. It then picks out a random rabbit. It keeps on picking out random rabbits until it finds one that firstly isn't the original rabbit, so this is the original female rabbit that it found in the rabbits array, and if it's not the original one and the one that it's picked out at random isn't a female rabbit, so it's now managed to get a male that can mate with the original female rabbit. It calculates the combined reproduction rate of the rabbit and its mate and creates a new rabbit. Note that the constructor used here accepts 2 parameters, and the new rabbit takes the combined reproduction rate of its parents. So we now return back to advanced generation again. This is the code that we've just executed. And finally, if there are no rabbits left in this warren and show detail has been set, then it will output this message that all the rabbits in that warren are dead. And we've now returned back to the advanced time period subroutine after calling advanced generation. If the option to show details was selected, we can call the inspect method of the warren. All this does is it simply outputs the number of periods that this warren has been in existence and a number of rabbits in that warren. We then check if the current warren has died out, and we do that by calling warren has died out. You can see again this is going to return a boolean value. It's part of an if statement, so it needs to return a true or false to work out whether to branch down this part of the code. And this is warren has died out. All it does really is returns a value of true if there are no rabbits in the warren. We can't just look at rabbit count directly because it's private to warren, and the advanced time period method that we're looking at belongs to simulation, so it doesn't have access to that value directly. If the warren has died out, then the warren is set to nil and we decrement the warren count variable. This is a private attribute of the simulation class. We're now on to the next block of code in the advanced time period method, and again this iterates through every position in the landscape, and this time it will check if there's a fox present at that location. And where there is a fox present, it will go through a similar process as it did for the rabbits. So this is advanced generation, which will do the following. It will kill the foxes that haven't eaten in this time period. It will kill foxes that have died by other factors. It will age the foxes depending on how much food they've consumed in that time period, and it will kill foxes that have now died from old age. Where a fox has died, and it calls the check if dead method, which again will return a true or false value to check if that fox has died, its object gets set to nil and the total number of foxes gets decremented. But if the fox hasn't died, we go down this else branch. In this case it might reproduce, and if so, new fox count gets incremented. Detailed is displayed if show details has been selected, and the number of food units consumed by the fox is reset, and this means it's ready for the next time period. So after iterating through every location in the landscape and advancing every fox that we found, we then check if new foxes were added after reproduction. Note that there was an error in the original version of the code here, and the original version of code would only allow new foxes to be created if show detail was true. This has now been corrected, and so you'll have the updated version of the code. This is the original code compared to the new version of the code, so you can see originally it would only create new foxes if show detail had been set, and this has now been corrected. So now the create new fox method is called for each new fox regardless of the value of show detail. This is create new fox. It selects a random position in the landscape and it keeps on doing this, so we've got a repeat until loop again, similar to the one we looked at last time. It will keep on finding a random position until it's picked a position that doesn't already contain a fox, i.e. you can't have two foxes in the same location. So once it's found a location that doesn't have a fox there, we can then create the new fox in that position using the new constructor there, and we also increment the fox count. And finally, having created our new foxes, we can call draw landscape again to show the updates that have been made after this time period has taken place. We then reach the end of the advanced time period procedure. And that brings us back. It concludes everything that takes place when option 1 was selected from the menu. As you can see, selecting option 2 has almost identical effect. The only difference is that the show detail attribute got set to false, meaning that all those lines of code that would have output details of individual warrens, rabbits, foxes, etc. wouldn't get called. Menu option 3 allows you to inspect a fox, so rather than advancing the simulation, this will let you look at a particular fox, and the user has to input X and Y coordinates, and this will call the input coordinate method. This is a private method. It belongs to the simulation class. It takes a coordinate and simply returns it as an integer. Note that there's no validation taking place here. This might be a fairly easy exam task to check that the coordinate that's been entered is within the maximum that's allowed for the landscape size. And once we've got those coordinates, it then checks that a fox exists at that position, i.e. it's not nil. The fox is not nil. Note that if there isn't a fox there, it doesn't do anything. Again, this might be an easy task for you to do, to maybe output an error message if you've input a coordinate for a fox where there is no fox. And this is the inspect method that's called. Note the first line here, inherited. If you're not familiar with the inherited keyword, this is the description from Delphi Basics. What it does is it has the effect of calling the same method for the parent class, i.e. in this case it calls the inspect method not from the fox but from the animal parent class. So this is the code which is called, and this code will output the fox's age, its ID, lifespan, probability of death by other causes. Note that these are common to foxes and rabbits, so the rabbit inspect could call this as well. So the fox inspect firstly does the things that are common to foxes and rabbits, calling the animal inspect, before doing the things that only apply to the fox. And these are the things that apply to the fox. The other attributes were common, these two aren't. So that concludes what would happen if you select option 3. If you choose menu option 4, then this is to inspect a warren. Again, the user inputs the X and Y coordinates, and again, these aren't going to be validated. If a warren exists at that position, i.e. warren is not nil, then it first of all calls the inspect method on the warren in that particular location. This is the code, and all it does is display the number of periods that have been run and the size, the rabbit count of that warren. It then asks the user if they wish to view individual rabbits, and you can see that this is stored in view rabbits. If they've entered a Y, then it calls the list rabbits method for the warren in that particular location. This is the code for list rabbits. It first checks if the warren has any rabbits in it, if rabbit count is greater than 0, and if so, it loops through every element in the rabbits array for the warren and calls the inspect method for each rabbit. This is the inspect method, and just like with the fox's inspect method, it calls the inherited method from the animal parent class first. So just like with the fox inspect, it will display the 4 attributes that are common to both rabbits and foxes. Once it's done that, it then outputs the attributes that are specific to rabbits, the reproduction rate and the gender. So the inspect method has been called for all the rabbits in the warren's rabbit array, and then we return back to the calling subroutine. And that would be the end of the code for menu option 4. And finally, recall that we're in this big repeat until loop, and it will keep on going round this loop, and it will stop when either there are no warrens left, i.e. there are no rabbits left, there are no foxes left, or the user has chosen menu option 5 to exit. You would expect the user to keep selecting options 1 or 2 to move forward one time period and advance the simulation until either the foxes have died out or until all of the rabbits have died out. At which point the simulation would end and execution would return back to here. This is where we actually started our simulation, and so the simulation would end at that point and we're back in this repeat until loop with the main menu option. Again, recall that this would allow us to keep running the simulator with or without custom options or 3 to exit. Thanks for listening to this. I hope you found it useful, and most importantly of all, good luck with your exam.